Okay, good morning everyone. This session is the future of BIM from cities to industry. And following on from a very interesting presentation from our keynote speaker in terms of the major challenge and major change that our industry faces is very significant. For the last 15 years or so, I've been, apart from working on BIM, I've been working on smart cities and smart city futures, and using things like triple helix models, involving government as a partner, industry as a partner, and academia as a partner. So those three ingredients are very important, that they are entwined as a helix, because we have to work together to achieve the policies, we have to achieve the benefits from academia in terms of research and new knowledge, and industry itself must change. So BIM offers us a wonderful opportunity to change design practice and being central and integral to the adaptation that needs to happen. What we have to recognize too, that the status quo is not an option. If we carry on the way we carry on, we will never change. All we'll do is add in another layer upon another layer upon another layer. So we will be suboptimal. And it will just be cost plus, cost plus, cost plus. So hopefully BIM will change and be the change agent to the functions, the procurement, and the practices. And we will become a more diverse and evolve as an industry and go through major change and major metamorphosis, together with a growth in specialization, specialisms, and increasing need for specialists. The two speakers today will no doubt have their own perspective on the changes that we need to have and what we need to do. So I will introduce Mads as the first speaker. So over to you.
Thank you so much. It's actually quite a great pleasure for me to be here for several reasons. Of course, there's all of you, and it's a huge pleasure for me to be invited by our colleagues in Spain, because it's up and running. But it's also a great pleasure to be able to speak after a longtime friend of mine, Martin Fischer, who's also a part of our board. My name is Mads Bording. I'm Group COO in RIB Software. I'm invited by my colleague Nestor, who represents Presto and RIB in Spain. The first confession that I will make to all of you is that I don't have physical mud on my boots, I have technologically mud on my boots. I'm not born and raised in construction, however, I've spent the last 20 years working in technology in various industries. Where Martin Fischer takes academic approach to BIM, to virtual design and construction, and to IPD, we, RIB, has taken a technologically approach to those exact same topics. So for that pleasure, it's a huge privilege for me to talk to you about our sentiments in regard to BIM and beyond BIM. So firstly, we need to address the context that we're all positioned in. Today, that mobile phone represents what is referred to as first screen, meaning that 83% of all interactions online are being done via a smartphone. It's not your desktop computer, it's not even your tablet, it's a smartphone. So the way that we interact with each other, ways that we collaborate with each other are changing from being something we do on a desktop that we do on communication while talking to each other, to doing it on our first screen. Similarly to that, we are playing around with augmented reality. When I spend weekends with my son, we go around chasing Pokemons, and we're in reality playing around with virtual reality, with augmented reality, but we think it's very complicated once we bring it into our business life, once we try to bring these technologies on site. We have to recognize that new companies are emerging. When we look to Airbnb and we look to Uber, we see new companies going into industries they've never been in before. Uber didn't have a presence in taxi driving. Airbnb didn't have a presence in hotel operations. However, they went global within 1 to 4 years. So they're coming with different structures, different business models. They're much more agile. So the IPD, the integration and collaboration, makes them act much swifter and much quicker than us stuck in a more traditional paradigm. Similarly, we've seen with Tesla, and Martin showed pictures from the factory Tesla is currently building for their battery packs. This is the assembly line for the Tesla Model S. Within 10 years, Elon Musk and the Tesla company has completely changed the way that we do automatic manufacturing. Since Henry Ford, we've been talking about mass production. What Tesla is now offering is mass customization, which again changes the supply chain and the interaction between stakeholders. You as a client of a Tesla can specify exactly what you want and you can track your car on the assembly line till it rolls out. So the supply chain is changing. The business models are changing. The interaction between stakeholders, collaboration is changing. Thus, we need the integration in the processes to deliver the quality products that we demand. So what's the outcome of thinking differently? What's the outcome of doing things differently? Sticking with Tesla again as an example, they've achieved to run their company to a state where it currently has a higher market value than Ford. And mind you, the Ford has spent 100 years more than Tesla producing automobiles. So this is the context that we're living in. We're living in a context where we have new structures in companies, where we have migration of technology from one industry to another, where we have to learn faster and adapt quicker in order to produce better products and services. We see exactly the same thing happening in construction. Augmented reality is entering the scene of construction. Integrated project delivery is entering construction in the way that we work and the way that we see the future. And this is exactly the space where we, RB, our company, is positioned. Over the remaining course of my presentation, I'll share 3 elements with you. I'll tell you briefly about our company. Some of you might not know RB. We started out as a small company, but we are growing at immense speed and pace. So I'll make sure that you know our company and our philosophy. I'll also briefly touch on our product, which is referred to as I2, the integration of 2 processes, which is basically taking integrated project delivery and collaboration, combining that with BIM in a software package. The reason why we think that's vastly important is exactly linking to my introduction of different business models and different supply chain models. We refer to that as Y2, which is a joint venture between Flex and RIB. But bear with me, it'll probably all make a lot of sense in a while. Our company goes back till 1961. Back then we used to do estimation software. I wasn't even born yet. We were headquartered in Stuttgart, and these guys did great. They did fantastic. Very good tool. They grew over the decades and became a market-leading standard in Germany. Being headquartered in Stuttgart, we have companies such as Porsche and Mercedes-Benz. And some of the very bright fellows working in our company, they started to reflect over why automotive were making much more money and were much more productive, and guys like Martin wanted to research automotive and not construction. So they knocked on the doors and started to talk to these guys from Mercedes-Benz and Porsche to understand their way of manufacturing, their philosophies. And 2 key points came out of that, and that was that they operated with integrated processes, so not segregated processes as we see very often in construction, and they worked with integrated technology, meaning that there's no information silos, that there's transparency, and there's free flow of data. That led us to realize that we're, in reality, having an estimation software wasn't a part of the solution, but rather a part of the problem. So we skipped what we were doing and started to invest heavily in building our product I2, which has taken us from being a German company to being a global company. What we're aiming to do, and that's just bringing the facts to the table, is that taking the lessons learned from automotive and trying to apply the same philosophies and the same transparency to construction. And it's not because there's not potential there. Martin, he showed some concrete examples of projects that has been delivered much more efficiently. We benchmark against what other industries are doing and how they're able to add more value for the same cash going into the processes, whereas in construction, it's rework, it's waste. We can't do that alone. So as a company, we retain a very open and persisting willingness to work with other companies, with other organizations, one of which is, of course, Sci-Fi University and Martin Fischer. It's consultancy companies such as McKinsey. The philosophy in behind that is all brains in the game. So just as our technology, we have an open philosophy that we need to bring everybody together that can add value to changing the processes of construction and the way that we work together. That means that we work with a lot of forward-thinking companies that are buying into the opportunities to change business models, to change structures, to change their way of work. And again, this is tapping into change management. This is not simply about buying a product. This is about understanding your core processes, how that links to people, and let the technology be an intermediary between all of these. That leads slightly into our product, because venturing out with a great idea, what we found quickly was that the vast majority of the people that we meet, the companies that we meet, they're operating in a silo system. We know the process of how to build and deliver an asset. We just simply don't have the infrastructure to support that process being lean and being transparent. That's why we see all these silo systems. We see a lot of rework, and we get tied up in a very project-centric focus on what we have to do, and we forget the fact that we are actually doing a project as part of an enterprise. So we don't have these feedbacks and double loop learnings, and we don't take the knowledge that we have in one project and bring it to the next. So mass customization is virtually impossible. Mass production is virtually impossible in that context. So where we begin is to recognize that all of you working in construction are actually part of a big data ecosystem. You have massive amounts of data, some of which are stored in your brain, some in spreadsheets, some on internal drives, etc. But we need to create a common language, a foundation. Just as the BIM model can create a visual representation of what it is that we are communicating about, the raw data is also supporting that language, getting a common language. All of this raw data needs to be structured so that we don't have data as a utility, but we have data as an asset. Data allows us to understand what it is that we need to do at a current point in time. It allows us to analyze and be much smarter. It allows us to make better decisions. And that's across the enterprise. Because all these elements have a knock-on effect on each other. We're working in a causal system. If we change a building material, that will have a cost implication, that will have a time implication. So having big data, having structured data creates a foundation to understand change, and it allows us to work in a virtual environment before we go into a physical environment. And that's the core process of working in I2. I2 stands for the integration of two processes, the virtual process and the physical project. This is what Martin referred to as virtual design and construction. So what we'll do is that we'll run a complete virtual process, which is no different from the process that you're running today on every construction project. We'll just make sure that we benchmark every action and decision that we need to make against our big data system so that we can align that with the strategy that we have for the project. Does the project need to finish sooner? Well, then we have to escalate certain elements, and what's the knock-on effect of that? So we can do multiple of alternatives long time before we actually start the physical execution. The aim of that is take variation and variability out of construction. What we do today is that we solve it on-site, which is time-consuming, causes more error, and causes conflicts where we have the contracts that are keeping the stakeholders apart instead of working together in unity. When you have a system in place such as this, and I'm not talking about the software, I'm talking about the processes and the understanding and the data, you then have the possibility to connect to other systems. You then get a strong foundation for openness. This is talking Industry 4.0. This is talking machine, human, and interaction between various stakeholders, supplies, etc. And that leads to the next part of my presentation, which is the Beyond BIM part of my presentation, addressing a joint venture that we made recently with Flex. For those of you who don't know Flex, Flex is the world-leading supply chain company. They have built verticals in 12 other industries, construction being vertical number 13. What they do is that they go to all the material suppliers in a given industry and they connect with them via a digital platform. That means that we have building blocks that we can now put on a supply chain system that can be linked to the VDC process and linked to the BIM model. So that creates an end-to-end ecosystem where all these stakeholders will work together. The capacity in working with Flex in this Y2 setup is tremendous. We have over 800 engineering specialists working in this. We have over 10,000 people with supply chain knowledge tapping into this, and we have over 4.8 million square meters of production globally looping into this joint venture. In trying to roll this out, when we do a design, we know which elements go into a project. When we have a model that we can utilize to build, we also know the components, and we can schedule that, and we can take the quantities off. In Y2, we are trying to create what we refer to as demand visibility, really understanding which components goes into this asset, understand the time and cost implication all the way out to the suppliers. So in a very similar way as Tesla is operating in their made-to-order production of cars. By bringing on and creating integrated processes with the suppliers, we can then ask them, do you want to produce these items in this order or that order? How many units is preferable for you to bring on site? We can skip all the links in between so that we get this just-in-time delivery of all the building components that we need. That demand visibility is helping us to take out variation and variability, and of course all the elements that drive cost in executing these projects. Many of these things, they don't exist today. So we've taken it upon ourselves to make sure that for each and every project there's a catalog of the BIM data that you need. Martin talked about an example of everything less than 1 centimeter. If it's not in the model, that's probably where we're going to screw up. So we make sure that we have the transparency and have the data needed. This is not only geometry, this is also aspects going into operation and maintenance about the components that we put in to this supply chain loop. This, of course, has paramount value, because if we can make this a lot tighter and take a supply chain and transform that into a value chain where all stakeholders are adding value instead of just looking at their own piece of the puzzle, we get a transparency in regards to quality, in regards to delivery, but we also have a knock-on effect directly correlating with the cost of the building materials that which is supplied during this process. Benchmarking those, we've already been out and doing our homework. We did that luckily before we invested $120 million in this project. We saw that there are significant cost savings in doing it this way, creating this transparency, because there's only winners in this equation. So the suppliers were able to align their manufacturing processes with the demand and market, which meant that they could transfer those cost savings to the client. We saw that some of the same factories were actually producing white label products, which are exactly the same quality as the branded products, but the price of that is significantly less. So now suddenly we can give the clients options to choose what they want in their house. What do you want in your home? Do you want branded products, or do you want white label products? We create that demand visibility all the way out to the client. So in a similar way as you specify your Tesla, you can specify your home, and you can make these supply chain choices. In that sense, technology becomes the intermediary, which for us means that we too need to reflect on the business model that we apply as a technology company. We too need to find a way to be vastly more scalable than we are in a traditional regime. For those reasons, we have applied a completely different business model for the Y2 Formative joint venture, where the technology is actually free. It's free. Once we have that transparency based on the BIM model and the VDC process, we were able to make sure that the right transaction volumes come onto the supply chain platform. And if we can give the clients 10-15% cost saving, meaning the contractual company and the builders, and of course the end client, then what we charge is instead a haircut of the transaction fee, which again puts everybody in a win-win-win situation. So paradigms are changing. Paradigms in the way that we interact with customers, paradigms in the way that we interact with and engage with stakeholders in the process is changing, and we have to adapt to that, because technology companies can move extremely fast, and we've seen examples of Google building their dormitories in the US, and instead of going the traditional way of hiring a client consultant and an architect, they started doing it themselves. For them, it didn't make sense to operate in this very segregated way. It didn't make sense because none of their other processes worked in that way. And they've created extraordinary results utilizing and trusting their own intuition and their own processes. So why should they do it in the conform way that construction works? So things are changing. And I want to show you an example that this is not science fiction, that this is actual reality. So I want to bring you to a production facility which Flex is setting up in Germany. This is for one of our Y2 formative clients. It's a home builder in Germany called C.G. Gröner. So they're doing this full-fledged. They're building up a factory for concrete precast elements. Being from Denmark, I like to refer to those as Lego bricks. So they want to simplify what they're doing. They want to output Lego bricks so that we take complexity out of what we do on site, and we bring all the complexity into a controlled environment on a factory. So bear with me. A short video that should keep me well within time, but it'll give you a glimpse into what's going on.
Technology is driving the construction business into an intelligent and integrative level like never before. From project planning to supply chain management, smart technologies are improving the entire construction process to be faster and cost less. Construction processes now go virtually before physically in I2 5D. Design faults and risks are eliminated from the simulation. Cost calculations are automatic and visualized. Project schedules are predictable and traceable on smart devices. Material procurement can go directly to the suppliers online. And improve the last mile delivery through smart supply chain management. I2 Flex integrates I2 5D BIM cloud technology with supply chain platform and offers a life cycle project management solution to have in-time and in-budget project delivery. While the material requirement and consumption over time are accurately planned through I2 Flex virtual construction, a list of material requirements with exact items, amounts, and delivery time will be generated in the database. Sourcing will be finished online with I2 Flex product catalog. I2 Flex supply chain management connects data, materials, machines, and humans, and brings the confirmed orders into a just-in-time smart production in the supplier factory and a direct delivery for on-site assembling. It enables online collaboration between franchise members of Y2 and global suppliers, and parallel working between building elements production and on-site construction, thus improving the construction process with better budget plan, less waste, faster delivery, and higher productivity. Smart, efficient, green, and direct, Y2 supply chain management realizes data interchange among project stakeholders and streamline the process into an integrated and dynamic construction ecosystem. Running together, we build the next generation of living.
Even the smartest Silicon Valley companies have changed over the past 10 years. Apple used to do their own supply chain, their own manufacturing. Today it's Flex. Consumer demands have changed so that Nike needs to produce new sneakers quicker than ever before, tying into the quick demand changes with the younger generations. Flex is helping that. We're trying to do exactly the same by taking our VDC universe in I2 and connect that to Flex's supply chain, building the 13th vertical. Industry 4.0 is not science fiction, it's a reality. The technology is there. As Martin said, the processes, the knowledge, everything is there. All we need to do is to think differently, collaborate, and keep an open mind. And all of this can become a reality for everyone and our industry as a whole. RIB as a company, we're fully prepared. We're doing this every day. This is what we live to do. It's time for takeoff, and of course, you are invited to join us. Thank you so much.
Yep. Thank you very much, Matt. It's very much the future. Well done. Christoph?
Where is it? Yeah, this one. Okay. I don't know if it's still time to say good morning. Just to introduce myself, I am in the construction industry since 30 years, and I am in a generation we work always with digital information. So that is important to know that because we learn a lot about what does it mean digital information. And just to give you an image of that, that the first job I have to do in my company 30 years ago, it was to work on the drivers in order to be able to have our drawings plot on a plotter called Benson. How many people here are knowing Benson? Yeah. This is totally disappeared. That is, what does it mean digital? In 30 years, all of the main company in the information, digital information, are more or less disappeared. So it's important for the following. What is the future of infrastructure? That is a report done by Accenture for Davos last year. And they explain, yes, yes. And they explain what is going to happen in terms of business with the new revolution. And with the two arrows in green, it shows that we are speaking about the topics of today. That means on the other part, it means that the future is connected traveler and automatic driver. And the arrow on the bottom is to say that the infrastructure will be connected infrastructures. And on this report done by Accenture, they imagine the industry involved in that. You have car manufacturing, a new company, and so on, like Google, Uber, and so on. But no construction industry involved in that. So why? That has to be verified, and that means that the discussion of today is how we are be able to be involved in that with this new business. And what does this mean, this new business, and where is the BIM inside that? So it's the first, in this slide, you will see that what is the environment of the BIM and with this new technology. On the upper part is to explain that we are involving with big data, link data and big data. We are involving with new tools with simulation and mobile interface in terms of sensor to collect the information. On the middle, you are the software platform. We can say that the information system related to BIM. And then you have new technology to be able to use that, like additive manufacturing, 3D scanning, intelligent construction, and so on and so on. But what it is important, which is not said in this slide, that if you have not this software platform and control in this information system related to BIM, that means that everything around that will be not done by us. So that means that we have the option for us, if we are very good in terms of BIM, information modeling, we have this opportunity to be in the core of this new business. It's very important. If we are not able to do that, someone else is going to do that. And we know the name. We know who is the crime. That we know already. And the people using, for instance, Google massively with Google Map, we know that you have the competition between our view about what is the construction modeling for the construction, and the business around that. And what are the opportunities for us? And I mean, I'm going to reuse, I'm not going to repeat, but I'm going to mention what it was already said before, that we have the core of the system, and we have to be faced of how to use the new sensors to provide and to collect the information. To give you just a short idea, if you compare construction and medical domain, it's proof now that with new technology, with linked data, the people who have absolutely no knowledge in terms of medical science, just in using the data, are able to be more efficient in terms of to diagnostic the problem you can have in the earth. They are able to do that. So you can say absolutely the same thing about how to execute a bridge. You have the picture of the Uber cab with camera everywhere. So they are able to provide you the information in a scale, second by second about what's happened with the bridge. So we have to think about that, because if we are not able to use this information, someone else is going to use that. Okay, what does it mean? This slide. So I'm coming for this one. Our job, if we want to be involved in that, is to be able to manage the information around that. So we have two options. To say there is someone else is going to provide the modeling of that, or because we are there, we know what does it mean a bridge, or what does it mean a road, we are going to create the possibility to have this modeling. But not only to have this modeling, but to create the interoperability between all of this information. So the question of the interoperability and the standardization is crucial for us. For us, I gave you another one example. When we create in France the project called MINE, MINE is now an organization of 60 organizations, contractors, consultant company like mine, Aegis, or like Sistra or something like that, plus academic, plus on. At the beginning, it was to create the modeling, MINE mean modeling for infrastructures. And Google was part of the beginning. And they part to the first two meetings about that. And at the conclusion, they are laughing. They say, whoa, you are working for nothing because we are better than you, and we are going to create that for you. That's really what we want to do. But the question is, if we want to be able, the question is the following one. We are speaking about Internet for the things. And the question is it Internet for something or Internet for everything? It's totally different. Okay, I give you a picture. Now, Apple created the iWatch. What's happened with iWatch? Not so much. Because why? Because there is no the services, the right services associated to that. So in connecting the information, you have two aspects. See, how to connect, but connected for why. And our specialties in the construction is to understand why we need to connect. So that is important to be part of that. And I'm going to give you some example of what does it mean. If we are able to interconnect, and that's a question of, the interoperability, IFC, and so on is very important. Some example. The management of the underground, for instance, is absolutely important. So now nobody is able to know what's happened on the underground in terms of utilities, facilities, but also how to describe geological or geotechnical. That's the reason we have some works starting around Building Smart or around Mine or something about that. So examples of how to have the modeling of the underground with the utilities. So we have some experimentation about IFC and utilities. The second one is to describe the geotechnical or geological information. There is a big difference between the construction domain and the gas and oil industry. Gas and oil industry, as other two said from the very beginning, they need to have the description of the soil and the underground for one reason, because it's their business. If they are not able to have a view about the tank where there is oil inside that, they have no idea about what are their inputs. Okay, so they create standards without we are totally independent of the software vendors, because their asset is there, and the asset has to be totally independent of the software company. And we have to do the same about the geotechnical information for construction. That's the reason we are starting a project in Mine, according with also the idea of Building Smart, about how to describe in a standardized way the underground and the soil. You have also the application about the BIM. For instance, the spatial analysis, like digital planning and so on. So we are working in different directions. just to go briefly, we are working, Building Smart and OGC, about how to connect BIM, IFC, and CTGML. Why is it very important? Because if we are not able to provide services on BIM in how to use that, not for the construction, but for the other aspect, that we are going to lose services and business around that. And all of the spatial analysis, like planning application, if the states are not able to provide planning application under digital process, we are working for nothing. So I mentioned Internet of Things and sensor. We need interoperability. And with this slide I used yesterday, it's just to show what we have to know and what is the environment of all of the information coming about cities, infrastructures, and so on. So it's a world. It's a world. If you want to be able to manage a car or a train, you need to know everything about the right track, but not only the right track, but also the catchment around that, because you need to know the impact of the drainage about the territory and so on. So what we have to connect is the world, not less than that. So it's not a small affair. And then we need to work with all of the environment. It was very interesting, the previous presentation, because it showed all of the things we have to connect. And the question, coming back to this question, we need to connect the things for something, not for everything, but for something, to identify what you need. But if you want to connect an object to another one, you need to know all of the semantics around that. Okay? So that's the reason we have to, I give you the idea of what we have to do is to connect all of the information we have to manage. We have the information around BIM. We can see that what we are managing with IFC around Building Smart is one thing. But a building is inside a territory. And when we manage an infrastructure, we know that we have to manage the 3D geometric definition plus semantic, but inside the environment. And we know that we are using the GIS technology. So we have to combine that. And we don't want to replicate. We want to unify the model, but not to replicate, to connect the model together. So that's the reason we are working already with OGC to be able to have a common schema to be used for GIS and for CAD system. But we need more than that. That's the reason that the figure previously was what was interesting, because we have to connect also all of the manufacturing industry and knowledge with our own needs. That's the reason we have to work in a different way. And different way means with different horizons. So this schema is just to show that the works we are developing in ISO is oriented in this direction. For instance, in the presentation of Martin this morning, he was speaking about delivery. And everything he's speaking explaining by Martin is more or less now embedded in the ISO 19650, which is in progress to be accepted by ISO this year. Well, it's part of the work package number 2 of ISO TC 59. It's interesting because what I explained Martin was absolutely crucial. Hello? and it's available for everybody. It's explained how we are able to communicate together in terms of delivery and information delivery. And we have the liaison with the different organizations to create the standardization around the ISO organization. Okay. So, connecting objects. So, to be able to connect objects together, I'll come back, we have to know what is this object and what is the other one, and how to be able to connect the information together. That is a big problem. So there is two possibilities. to reinvent the wheel project, project by project. I want to connect a sensor on site to my computer. So I'm going to create that for this project. And a new project is arriving, I'll recreate the same things. So that's the reason when of the very important development we are doing in SEN and ISO is the question of how to connect the products. And the first step, it was to create data dictionary. And what we want to create data dictionary, that means that is to have a common view how to define a properties. I mean, how to define a length, for instance. If you say a Windows has the length, we are going to discover that you have at least 10 definitions of this length for the window. So we are creating a common way to explain what does it mean length. And then also to explain how to develop all of the properties around an object and so on. To have a common view about that. Not to say there is only one definition. So it's not the topic. The topic is to explain how to create a definition and how to compare several definitions. Why? Because you have not only one way to describe a window. It depends on the model view and so on, and so on. Okay, so to describe a property. And also to unify, not to unify, to combine the different aspects. And that is a good example of part of the electrical domain are already their definition. There is no reason to redefine in construction that. We have to reusing and to combine that. That's the reason the works about the data dictionary is oriented to combine from the other part of the standardization all of the definition and to embed that in one vehicle, able to compare that. In order to have a common view of what does it mean the properties and to have some common definition of all of this for these properties. And what is very so useful? Because if we are able to proceed in this way, that means that you will be able to recover this information in the different standards, able to exchange the information. Okay, and the idea is to have this kind of networking or different data dictionary in the world, domain by domain or nationality by nationality, in order to be able to share the information, to compare the information, and to have at least the metadata around that. That means what is the status of the information? Is it used? Is it confirmed by the experts? And so on and so on. Because the figure is this one. The future BIM level 3 is that. It's not only your system information, which is based by a full standardization. When the people are speaking about full BIM, what does it mean full BIM? In first, full BIM means the full standardization of the information. To be able to use international standard, to be able to exchange the information. And the secondly is to be able to have able to use the metadata or the workflow about that, the status of the information, the collaborative tools to compare the information. And then what is important is to connect this information with the others we are not able to manage, what we can call the big data. And big data means a lot of information, not structured. And the question is, if we're able to connect this information, we need to have this tool about data dictionary and so on, because there is two aspects about that. I suppose data dictionary is to be able to know what we have to connect together, but it's also to have a view of the full life cycle. That means that what is information is used for the design, important for the design, what it is important for the construction, what it is important for the asset management, and what it is important for the facility management. And to be able to identify that. That's really what you have to know and to do together if we want to be able to participate to this new business around the link data, the big data, and the internet for something. Thank you very much.
Thank you, Christophe, and thank you, Mats, for this. I think we don't have any time for questions. Ignacy? Do we have any time for questions? One question. Two questions, okay. Who'd like to ask the speakers? Yeah, okay.
¿En español? Me gustaría preguntarle a Mats.
I would like to ask Matt something that I already asked, and I already know the questions, but I would like to share this comment. Flextronics has already entered into 12 sectors, and the 13th one is the construction sector. So we always say that construction is different, is a way more complex industry than the other industries. We build a prototype one by one and so on. So I would like to know if the people of Flextronics has realized that construction is different, is a different sector.
You are not getting a translation?
No.
Sorry.
So I understood because I have the translation.
May I do it in English? So this question, Mats, I did this question to you, but I'd like everybody to share. So it's about Flextronics. They have gone to 12 different industries or verticals, and now they arrived to construction, which is number 13. And as we think, in this industry, we think is special, difficult, different. I would like to know your feeling, your opinion about Flextronics. Are they finding construction as a normal industry, or do they realize now that it's that is more difficult, that is specifically different?
This is actually a very good question. And from the conversations that I've had with Mike McNamara, the CEO of Flextronic, whenever they went from one industry to another, there was this perception that our industry is completely unique. As I mentioned before, I haven't grown up in construction, so maybe I'm a bit naive. Construction, that's concrete, that's glass, that's steel, that's time and material. So it's not necessarily much more difficult to build houses and build computers, etc., etc. What Flex does, and what they are better than anybody else in this world in doing, is to take competences and knowledge and learning from one industry and apply it to the other. This is exactly the same all disruptive companies do. They take something which seems to be extremely complicated and they ask a lot of stupid questions. You'll find that I do the same. When I arrived in the airport, I started to ask stupid questions to the cab driver. I'm always the stupidest guy in the room because I need to understand. So they ask questions and questions and questions and questions, and then they find structure and logic to that. And they can bring in knowledge and expertise from other industries. Because we're fooling ourselves if we believe that construction is more complicated than automotive, than building windmills and building condi shoes. It's not. It's different, yes. There's different parameters, but it's not more complicated. So we're fooling ourselves if we get stuck in a paradigm saying construction is complicated. It's not. But there's big issues, and we need to focus on the big issues in order to drive out the benefits. And that's what gets me excited when I wake up every Monday morning and I tie my shoes, because I'm actively taking part in that movement. And I see all of you being here because this is something that interests you. So collectively, we are trying to change an industry, and we see new companies coming in and joining that movement. But no, it's not more complicated.
Yeah, okay, to see, if we are speaking in terms of system engineering, the answer is yes. It's much more complex. The definition of complexity, the definition of a complexity in system engineering is very simple. Very simple. How many interfaces are you able to manage? So if you come back to my slides, or how many domains are we able to manage? There is no other industry able to say that we are more domain than that, because all our domains are there. So that means that if you are in charge of railway infrastructures, that means in terms of complexity, it's the top of the complexity. It's more complex even than a nuclear plant. I'm also involved in nuclear plants, so I can say that. Okay? It's very complex. And second things, which is totally different of the others industry. So in what we are not working in a 3D like autonomy domain. We are not working in the cube. Okay? If you want to describe a town, or railways or an infrastructure, you are not able to describe that in a 3D perspective like the other industry. You are not able to embed all of the territory, all of the town in a cube. If you want to go inside to implement, you are not using XY information like a cube, autonomy domain. You have to reinstall. The name is very simple, geospatial information. And even with geospatial information, that means that you are working on the figures which are much more bigger in terms of, you are at least, to say 10 number before the comma, and at least 6 after the comma. So there is no other domain to manage that. That's the reason we have to take care that all of the industry has to learn from the construction if they want to be involved with that. I'll give you a single example to finish that. That Dassault system is a perfect example of that. They try to work to develop the software in the construction industry since 30 years or 40 years. Now they are able for several reasons, but they are very much involved in us to developing if the IC bridge, IC rail, and so on. Why? Because we are providing this specification for them. That's the reason we have to be involved with that.
Okay, thank you. Okay, another question? That was a big question. Yeah. Maybe ask Matt. The industry is very traditional. There's so many vested interests.
Clearly.
It's undercapitalized. It's resource intensive. It's risk averse, and it's highly litigious. So how do you think you're going to make this step change with what I see is really the future in terms of off-site manufacture?
Well, it's proven to be the case in many other industries, so I don't see why it shouldn't be the case in construction. But this is basically talking about change and change management, and no change will ever happen without people having motivation to do so. Because in reality, it's much easier just going up Monday morning, going to work, and go home to the family at 5 o'clock. If you want to do great, however, you need to invest some of yourself in doing things differently. So you have to decide for yourself what kind of a life you want to live. If we look to construction today, we still, as construction companies, try to do everything in Michael Porter's supply chain model. So we basically need to be expert in quite a few disciplines to succeed. What we see in other industries is that they have put focus on what they're good at. Apple is a fantastic example because what are they good at? They are awesome at marketing. And they're awesome at building good interfaces for or UI and UX. The rest, it's outsourced. So they focus on their core competences and they bring in partners that does stuff better than them. So that's collaboration. That's what Martin Fischer was talking about. They do that in an integrated workflow where there are no vested interests because we're sharing the benefits of working together. But all of that started with people realizing that if you're trying to be everything to everybody at once, you'll fail. And I think that we have to come to the same realization that we need to work with smarter people than ourselves. That you'll rarely find yourself in a position where you're the smartest, the fastest, and the strongest. So why not join forces?
Christophe, do you want to say anything?
That is true. That the question is, that's the reason the presentation of Martin was really important. Is how to manage the change. That is the more complicated. Everything is complex, what I said previously, but the more complex things is how to manage the people to move forward on the change, and that I could say that is. But there is what we have to do inside your company, and what I want to absolutely to underline that. There is a time for competition together, and the time we have to combine our effort to be able to survive. and the construction. I mean, there is, and I can say that. Like, I hope there is not so much people coming from Asia, but I mean, there is two things arriving: new kind of competitors like Google, Uber, and so on, reinventing everything with their own tools, and we have also a big competition arriving from China, from Korea, and we have to learn about that. And that's the reason we have cooperation with them, because we need to work together on the new market. So that you have the time for competition and the time for collaboration to be able to have this way to work together. A BIM with no collaboration is not going to work at all. But it's very important to have that. And our feedback about that, I give you, if you have time, a short example. We have won the first award for a BIM project in infrastructure in France with a motorway. It was a PPP contract we have with BIG for this motorway. And we are able to develop BIM together because we work since 10 years about developing BIM for infrastructures. But when arrived the time of the contract, the main difficulties was to be able to have a common acceptance of the level of the quality of the model. And the question was not coming from technical issue, it was coming from contractual issue. Because if we have the common approach, a common agreement of the status of the model, then the times of claim is changing a lot. Because the claim is a question of the money and how we are going to save money of the contract. So I think that the behavior is very important, and the collaboration is so important with BIM.
Okay, that ends this session. So I'd like to thank our speakers for their excellent presentations. Thank you.
Thank you.